Well, I consider myself to be an optimist and not one considering a retreat. But after some of these maps that I've seen up on the board, I'm particularly the water table map down in Worcester Square. I'm starting to think about maybe moving. So, we've explored quite a range of topics and scales, and I'm now going to take you down to a kind of regional and local scale and discuss ecologically based land use planning and site-level green infrastructure focused on mitigation and adaptation strategies. So we know that coastal communities face a precarious future. Sea level rise and increased storm surge events, intensities, frequencies, we've heard all about it. Nearly 1 in 10 persons are living now in low elevation coastal areas, and the predictions are that that's going to increase over time. So we know we have these issues. There's a lot of money invested in these zones, as the senator was mentioning. What are we going to do? Given the private property and high land values, as well as the infrastructure, some of it aging, along the heavily urbanized U.S. eastern seaboard, the challenges are actually quite complicated, and they're the kinds of risks and concerns that keep people up at night. So what I'm trying to do through my work bridging ecological research and urban design is to kind of have a sort of back and forth and a kind of feedback between scientific investigation and scientific input, but also action-oriented planning and practice, and try to communicate that through a local level kind of collaborative effort, both that builds on education and on communication and on site-specific local knowledge and concerns. One of the things that historically has been a focus is this issue of managing risk, a problem-solving approach, really, that's often reactionary. The repetitive loss properties is one example of this kind of concern, where you're repeat property loss, there's an idea, well, let's spend money on that, let's try to solve this issue. I'm going to kind of present an alternative to that. Part of it is shifting into an idea of creating resilience and kind of interdisciplinary, building an interdisciplinary innovation and also considering the potential options for development of infrastructure along these tough zones. So if you look at the bottom, the Sikorsky Airport area, you can see what happens over time. The dark blue is high confidence in sea level rise, less confidence in the lighter blue. And as you can see, the green and red, there's some areas that are constrained in terms of migration potential, other areas where there's potential for migration. Keep in mind that along Long Island Sound, we have a lot of existing tidal marsh conditions. And those tidal marshes are critical or have been identified as valuable in terms of wave attenuation and control of some of the flooding events. And so part of the question is, what do we do about these intertidal landscapes that are often placed between development and infrastructure, and so they're caught between the forces of topographic constraints and rising tide? How can we actively accommodate these factors given the tidal marsh conditions are so critical, and also for nursery habitats for species that are supporting fisheries and tourism in Long Island Sound? The Long Island Sound Stewardship Initiative has an interesting task ahead of them. They're looking after, I think, 33 stewardship sites, all of them pretty much low-lying, most of them low-lying. So the question is, over the next 80 years, what should their planning mission be for land that, and many parcels of land that are essentially predicted to be underwater over time? How do they manage for that? What do they think about? Do they shift their agenda into an alternative, maybe thinking about, as they are now, starting to think about local communities and the adjacent conditions? So coastal cities and towns, in my opinion, will likely be forerunners of climate change adaptation and mitigation because people live there, people are concerned, there's money being spent, there's potential for innovation. And this is an image of Guilford looking at 2080 sea level rise and identifying some of the critical areas in orange that are existing on site. So it was mentioned before that I've been working with Guilford and the Nature Conservancy on the Coastal Resilience Plan, so I have a fair number of images from that site. However, uncertainty and severity and frequency of climate change impacts, as well as limited financial resources, limited regulatory scope of local governments, the unequal distribution of risks, the uneven understanding and interpretation of impacts and adaptations, adaptation options, and differing values of citizens, experts, institutions, and decision makers, they all challenge local adaptation efforts. So working with coastal communities, one thing that I've realized as Tony has mentioned on several occasions, is that climate change is a complex, wicked problem, as we like to call it. So I thought I'd make a couple graphs for today's lecture because I predicted that some of there wasn't going to be too much well, I thought I was the last person. I wanted to keep everyone awake. So as you can see, there's an XYZ axis looking at the kind of complexity of local scale issues all the way down to household, neighborhood, institutional level, and thinking about issues over time, the kind of legacies that are already in place. For example, the Amtrak line. Maybe the Amtrak line will end up being actually a plus with sea level rise for certain areas because it's actually essentially an embankment along the coast. On the other hand, it creates all kinds of pockets of flooding where you have egress issues for neighborhoods. So there's also a negative. Then you're thinking about watershed conditions, local scale all the way to larger scale. With Ron's talk about increased rainfall, increased evaporation, there's all kinds of questions about the existing infrastructure that we have in place, the stormwater infrastructure, and how's that going to perform over time. One of the things that I've noticed with Guilford is the importance, or that there are these impounded marsh systems all along the Connecticut coast that are that don't function as well hydrologically, that often are the problems in terms of flood events. So they end up being problematic at the local scale, but they're also important fish nurseries and areas for resilience for these communities. So wicked problems, we've got, as I said earlier, some of these issues in terms of uncertainty of severity, limited complications in terms of financial, limited regulatory scope, unequal distribution of risks, uneven understanding and interpretation of risks, and differing values of citizens. And as I engaged with Guilford, one of the things I also realized was that the dynamic nature of the situation itself makes the process of coastal adaptation challenging. So as you can see here, a diagram here, if you take the FEMA 500-year flood, by 2050, that's essentially the same as the FEMA 100 is essentially the same situation. So you're getting this kind of dynamic condition because of sea level rise, the mapping, the FEMA mapping efforts, and the designation of land types, the choices that people are making for where they purchase, the flood insurance rate maps and the way that those relate to FEMA. All of these aspects actually make a very complicated situation in terms of information, real estate practices, legal issues across the landscape that are troubling and difficult for local communities to engage with and react to in a timely manner. So I also put this recent August 15th FEMA memorandum that actually puts a price on both the structures that are acquisition structures and elevation of structures. So historically, you'd have to convince the zoning board to allow or to potentially that your property was damaged and to try to get funding back. Now they've set a price on this where it's where originally the process to prove hardship took time. If the acquisition of structure costs now less than $276, or the elevation cost to raise your property costs less than $175, it's considered, and the structure is in the special flood hazard zone, then the benefit cost analysis does not need to be conducted to support the project. So in other words, this is a useful document from FEMA, not so easy to find, but what it's saying is if your elevation is lower than these costs, then you can move forward with and not go through all the legal challenges that are there for getting your property paid for. So the complexity of coastal resilience is also tied into the multi-jurisdictional nature and the socio-political dimensions between homeowners, federal, state, and local governments, all working within the context of this uncertain future. How do we prioritize and simplify issues and expand partnerships or change behavioral patterns and learn to compromise? The sheer magnitude of the risks can lead to inaction. And what are the roles of the different levels of government and how can they interact? And how does adaptation look on the ground in these coastal communities? What does it become? And what do local governments need in order to, as catalysts to move forward within this context? When we asked a group in town, the Guilford's Board of Selectmen, what was the most important actions needed to protect Guilford from increased vulnerability due to storm surge and rising sea level and climate change, 67% argued that these were physical issues. So basically infrastructure. Let's spend money on infrastructure to solve these issues. But when we asked what are the obstacles to effective action regarding coastal resilience and climate change, 89% said there was institutional and societal. So in fact, the problems are people and the institutions that we have in negotiating that. So I've been working with the Nature Conservancy, the town of Guilford, Malone and McBroom, partly funded through NOAA, on the Coastal Resilience Plan, where we're using the TNC's Coastal Resilience Model, which is an online web-based model tool that's accessible to anybody and can essentially give you some data and information about sea level rise storm surge events. So, and as I've been suggesting, in reality, in my mind, coastal adaptation requires negotiation at the local level for land use changes, in this case based on predictions. So you're going to a town, looking at maps of the future and trying to negotiate or talk about how to either retreat or accommodate or modify land use practices in anticipation of future conditions. So we really, so we need a kind of a process of engagement and a means of building partnership. One of the things that's interesting is by acting early, and Guilford is one of these towns that's kind of been proactive in this and taken this information into a process of engagement with the public, is that it's possible that they can create the kinds of management tools and tee themselves up for different various funding options. So there is value, I think, to pushing this forward. So one of the things I mentioned earlier was this repeat loss issue. So there's a number of houses in Guilford that have a repeat loss conditions. In fact, from the hazard mitigation plan, which was done in 2011, there were 12 houses that were repeat loss. Since Sandy, it's gone up to 60. But as we studied Guilford more, we felt as if the repeat loss properties, they provide the most obvious immediate need, we're calling the perception of risk, which is essentially future home buyers and those living in homes today. Their perceived risk of their neighborhoods probably down the line will actually cause greater loss in terms of, or greater loss to property and financial value. And this is a good, so in other words, this egress where where 130 homeowners can enter into their neighborhood, the more that floods and creates problems in terms of access to their neighborhood, that actually impacts 130 people, whereas the flood events, the repeat loss damages, usually impacts a few people on the coast. So what we're describing now as zones of shared risk are essentially these areas, for example, Satcham's Head, where you have the 130 homeowners versus the repeat loss area, which is a few houses along the coast. Keep in mind that some of the houses along the coast in Guilford and elsewhere are very high value, and so they're heavy contributors to the tax, in terms of tax base. So I just wanted to give you a scenario planning for how we start to move forward on recognizing this zone of shared risk. This is an area, Seaside Village. Maybe some of you have been to Jacobs Beach or the stone house here. Let's see. And one of the things that people often say, at least early on before Sandy, was kind of, what is this really going to be like in the future? Like, how is flooding going to look? Well, when you look at Sandy 2012, and you look at the sea level rise anticipations for 2080, it's actually pretty similar. So Sandy was actually pretty useful to illustrate to people what we should potentially expect in the long-term future. And in this case, it's not exactly about gathering more accurate scientific data to specify where this is going to take place exactly. It's more about getting people to buy into the concerns and the risks that we face, and local data, local information that people trust and can see and maybe even participate in. In one sense, that can start to shift this issue of uncertainty from the scientific community to the public conscience and where it really belongs. We all face this issue of uncertainty. It's not just the scientists. So we developed a planning process for this area of Seaside Avenue, which essentially is mostly marshland. So you have all this marsh conditions. You have this development area here, and you saw the plan before. This is all underwater, or anticipated to be underwater by 2080. Here's the road. This is a bit of a radical plan. We presented it to the public in July, and people were actually pretty enthusiastic about it. So the town owns this parcel here. The first thing to go is really going to be septic tanks. So what we proposed is acquiring parcels in the lowest lying area, converting this using a cut-fill landscape where you would develop living shorelines and high points that you would start to develop communal septic, so you could maintain the several of the other houses over the longer term. rather than retreat, what we're proposing is actually to increase recreational opportunities along the coast. And there's a kind of zone that's slightly inner from the coast where you can actually increase development and give people in that inner area more access to the coast and start to recreate the coastal landscape as a coastally adapted landscape condition. So essentially, all along here, there's an Amtrak station here. There's an idea for Town Center South, which is a transit-oriented development. So we encourage this notion of a sending and receiving zone, that you would develop a sending receiving overlay where people could basically shift development into this inner zone area. And over time, you would start to get a kind of buffer. You would develop these living shorelines, not in the water itself, but actually upland, using rolling easements, so that you're doing lower cost, anticipatory land management, landscape alterations that provide new types of housing that actually are situated on living shorelines, so that the houses themselves have easements so that the town can go through and manage those living shorelines over time, and you don't walk out of your house and have your lawn abutting the wetland in competition with the marsh migration. And so over time, the idea here is that Jacobs Beach would start to move back and become a kind of recreational destination beach that also functions as a shoreline abatement, so that this whole area becomes essentially the wetland living shoreline combination that protects the rest of Guilford, while also enhancing development, increasing development, and creating a recreational amenity at the base here. With some alternatives. So early on, you would do some cut-fill landscapes, create a boardwalk system for birding, develop living shorelines. And this endpoint here would either be maintained as housing or would eventually potentially be purchased by the town as destination spots, part of the recreation zone. So, okay, that's at a large scale. And I wanted to zoom in briefly and talk a little bit about sort of local scale actions as well. So one of the challenges we face is how to get people involved in understanding their coasts and participating in kind of an education process around coastal adaptation. This was in Bridgeport, where we were working with Seaside Village. And we designed this both as a research experiment, because one of the things we do need is more data and information and more monitoring on existing ecological dynamics on the coast. So using a kind of coupled system with funding for experimentation, but also funding through EPA for sustainable community development, we identified the site in Bridgeport that was once wetland. It's in the 100-year floodplain. We developed what we called a mapping effort with looking at sub-basin watersheds. So we knew the site flooded quite a bit, and the area where we installed our system is here. It drains this parking lot so that they have the parking area now accessible to them. We started out with this idea of developing green infrastructure across property lines. The goal was to try to say, if you're, rather than your neighbor being the person across the street, if you think of your neighbor as your sub-basin watershed neighbor, and you kind of work collaboratively, you can actually develop green infrastructure that can support the city's issues in terms of water. Their sanitary system is maxed out, and they're looking for ways of holding water upstream so that they're not having everything flow all down at once. We developed this hydrologic distribution system to relay water to each of these 6 swales, but we also designed it as a public amenity with a floodplain grove and 6 swale systems and a pathway system that has an underground perforated pipe for resilience and increased drainage capacity. Here's a hydrologic system that we designed. And we got the community involved in planting the effort. And actually post-Sandy, because of the incredible salt inundation, we're back out replanting, because one of the challenges in these intertidal areas and these changing landscapes is actually designing a plant palette that can perform given the contrast of dry out and heavy rain and salt conditions. So this is it here. This was actually in the neighborhood during the Sandy event. So the interesting thing is that the whole neighborhood floods periodically with these major storm events. And then this was our site through the winter. So it floods as well, but it's pretty resilient over time. So to summarize, I just want to say that we're in this stage now where, public awareness is growing. Big projects are coming down the pipeline. Right now, we're trying to do projects that are small scale, that are sort of no fail, that are successful, so that we can share these methods and start to convince the public of the value of these systems and how they can work in your neighborhoods. But over time, the idea is to start expanding these and push them forward. And that's it. Thank you very much.